A Portland Community College Mathematics Telecourse. A course in arithmetic review. Produced at Portland Community College. You have probably asked at this point, why percents? What are they used for? A business friend of mine, when I asked him what he would tell my students, simply said that the percent is simply the tally unit in all of business. As in any game, you have a basic way of keeping score, keeping track of where you are. That's what the percent does to business, as you will see in the next 2 units of application problems. For instance, simple sentence statements like these following 3. What is 12.5% of $30,000? Or $240 is 18% of how much? Or $360 is what percent of $4,000? Such statements as that is the beginning of most business situations and most business questions. And to proceed with the business, we have to be able to answer those simple questions. In fact, the desire to be able to solve these types of problems is perhaps one of the principal reasons for most students to be taking this particular course. We shall develop 2 simple techniques for doing this, that is, solving this type of simple problem. But first, let's develop a technical vocabulary used more in business than even in mathematics. If you have a simple sentence where we say something called A is something percent, here we symbolized it by R, of something else, here called B, or something percent of something is something. Now naturally they don't use these particular letters, they use numbers or words. Well, in business, the number attached to the percent we call the rate of percent. Notice in both cases, R, the rate of percent, is the number followed by a percent. So if you can remember that, the number followed by the percent is what business calls the rate of the percent. Hence our calling it R. B in these 2 sentences is called the base. Notice in both cases, B follows the word of. So in a simple statement like this, a simple sentence, the number following the of we will refer to by the word base. And A we'll call the amount that is compared to B. Hence the use of A. And notice in this case, A is before is here and is after is here, but in either case it's attached before or after to the is. And the B, again, is before or after the word is. Now these 3 items, particularly if you are to go into a bookkeeping or an accounting course, is best to be memorized. Note and remember as soon as possible that the number followed by percent we call the rate of percent. Also remember that the number which follows of, business people will call the base of the transaction. And the number which is just before or after the word is referred to as the amount. Now remembering the word base, rate, and amount is more necessary for talking to your business colleagues. In math, we'll develop some simpler techniques. It will help for this technique to learn and remember these translations. That the word percent, whether it's written this way or this way, they're both words, means in math times 100th. Whether you choose to write it as a decimal or as a fraction, whichever you prefer. The word is, or in any form of the verb to be, generally translates to equal. And the word of translate to times. And the phrase what, how much, or any phrase designating the fact that you don't know something is replaced by a variable, a letter, to stand for the number you don't know. Again, percent means times 0.01, is means equal, of means times, what, how much means an unknown. Memorize this very quickly. This is where our working tools will come from. An example, 240 is already mathematics. But the word is, when translated to mathematics, becomes equal. 18 is already mathematics, so that becomes 18. Percent is not mathematics. It becomes times 0.01. Of becomes times. And how much becomes my unknown, and we can use whatever letter we wish. However, we might as well use be, since it follows the word of, to get used to the word base, which is one of our business words. Now we have a simple equation which we've been learning to solve throughout this course. Notice in this case it says 18 times 0.01, which if I multiply is 0.18, times b. This side we will leave alone. Now, had you wanted to, you could have changed this into this all in one move. But now you recognize that this is an equation where the unknown has a multiplier, and to undo multiplication, we simply divide. That undoes that, leaving me with my unknown base b. And on this side, we simply divide this either by hand or by a calculator. And we get this dollar value rounded to the nearest penny. So what we do is to translate each mark in our simple sentence to its math equivalent, thereby getting a simple equation we have been solving all along. So we simply solve for the unknown, and we're done. This method in your textbook will be referred to as Method 1. There is a second method we'll refer to as Method 2, which involves simply memorizing a small formula, that the amount over base is equal to the rate over 100. And that's a proportion, one fraction set equal to one fraction, and we just recently completed a whole chapter on how to solve proportions. This perhaps would be easier to remember in this form. Simply remember is over of equals percent over 100. Most math teachers prefer this form, but most business instructors perhaps have not seen this form, and they prefer this, because to them amounts, bases, and rates are simply the tools of their trade. Let's solve that very same problem by this method. We simply ask what number is attached to the is, and we can see the 240 is. Not the 18, even though it's against it, because the 18 clearly is attached to the percent. So the is replaced by 240 in our formula. Then we ask what number is attached to the of. Well, that's how much. So I'll call that by a letter. In this case, B, because again base is what follows the of, but any letter would have done. Equals, percent is clearly the 18 that's attached to the percent, and then this 100 is simply a constant to this type of situation. Now remember, in solving a proportion, we take this top times that bottom, set it equal to this bottom times that top. Then divide both sides by the multiplier of the unknown. Then do the division. And you're done. In time, with a little bit of practice, you will probably end by preferring one method to the other. If all students preferred this method or the last, it would be the only one taught. But about half will prefer this if they're good at proportions, and the other half will prefer the method we just had if they're good at solving simple equations. It's a matter of preference, not a matter of ease. Let's solve another problem by method 1. Method 1 could actually be called the translation method, because it simply involves taking each word or number and translating it step by step to mathematics. See, 360 is mathematics. Is equal. What is my unknown? Percent means times. 0.01. Of means times. 4,000 means 4,000. Then in this equation, any arithmetic that is indicated that you can do, do it. So this says times, and it's between these two. So I'll do it, and I'll get 40 times the x. And if you have an equation where the unknown is being multiplied by a number, you undo the multiplication by division, and now you have your answer. X is 360 divided by 40, which is 9. So as it turns out, 360 is 9% of $4,000. Let's do a problem now by method 2. And method 2 could easily be called the is over of method. You simply set up the bare bones of a proportion. Notice that we always have 100 here. Now you simply ask what number is attached to the is. That's the 360. What number is attached to the of? That's the how much, my unknown. What number is attached to the percent? That's the 18. Now you simply solve the proportion. Top times bottom, set equal to bottom times top. Divide both sides by the multiplier of the unknown. Do the work, and you're done. And we have $2,000. Very simple, both techniques. In one case you memorize a little proportion, in the other case you memorize sort of a small 3 or 4 part dictionary of English to mathematics. Let's do another one by method 1 now. That is the translation method. Word by word now. The word what is my unknown. The word is equal. Now in this case, let's translate this all at once. To get away from a percent, we move the decimal point 2 places away. We have 0.125. The word of is times. 3,000, 30,000, of course, is mathematics. Now in this case, we're lucky. We're done really except for arithmetic. It says my unknown is that times that. So doing that multiplication, we get $3,750. See how valuable that those exercises of solving equations have been all along in this book? Now let's do yet one more problem by method 2, or the is over of method. What number is attached to the is? It's the unknown. What number is attached to the of? 30,000. What number is attached to the percent? 12.5. and of course the constant 100. Now top times bottom is 100 times x equals bottom times top, which we could do by hand or with calculator, and we would get 375,000. Divide both sides by the multiplier of the unknown, which is a power of 10 here, and that's one of our shortcuts. So my answer is $3,750, which is 12.5% of 30,000. Very cute, but very easy and effective methods. Most problems, in fact, that occur in science or business usually involve fairly messy numbers. And there's where calculator use is very, very convenient. And if you have been following the proportions review parts of the last 3 lessons, then we have a peculiar shortcut for this, particularly if we use the is over of approach. Method 1 works just as well, but in this particular approach, if we simply set up our working proportion, then replace these blanks, these words, and this is a word, with the appropriate number or variable, we get, let's see, 558.37 is attached to the is, so it replaces the is. What is attached to the percent, isn't it? It says what percent. So that's my unknown. Let's call it P for percent. And of course, of is attached to the 73.98. Now, with our shortcut we've been playing with in the last few lessons, we can work this out in one smooth move on the calculator. We find the 2 diagonals, the one without the variable and the one with. The one without the variables we multiply, but we can multiply this mentally, can't we? 58.37 times 100 is simply 58.37. Then we divide by the number on the diagonal with the variable. So divide by 73.98, and we're done. And that is my percent. At this point, we'd have to ask whoever we were doing this for where they want us to round off, and that will generally be the case. So remember, this number is going to be the percent. So let's say that they had asked us to round this to the nearest tenth of a percent. Well, since this already is in percents, I can see it's going to be 78.89, and the 9 rounds that 8 up to 9. So we can say my percent is 78.9. Usually, we stick the percent sign back on just to let them know that it is a percent we were talking about, and to emphasize the fact in our minds that this number and this number are truly quite different. Okay, so with your calculator and with this is over of method, you can solve most of these simple story problems by inspection alone. Please note that it's this relationship and these words that makes this pattern work, not the numbers themselves. Here I'm using exactly the same 2 numbers as the problem we just worked, but reversed. But reversing the numbers changes the entire problem. In fact, before we set up our formula to solve the problem, let's get a feel for the fact that this is true. Now note, we know that 100% of something is itself. So this is certainly more than itself, this number here. So it's got to be more than 100%. Whereas this is certainly less than that, so it has to be less than 100%, which it was. It was 78%. So here again, using the is of technique, we start reading the sentence, and find that the 73.98 is attached to the is, therefore it replaces the is in the formula. What is attached to the percent, so it replaces the percent in the formula, and what is just another way of saying variable in algebra. And of is attached to the 58.37, so in the formula it replaces the of. And in this particular formula, this always stays as 100. Now here again, let's say that in this problem we also want to round to the nearest tenth of a percent. And again, let's use our calculator shortcut on this, recognizing that our answer will already be in the percent that I want. Here's the diagonal that doesn't have the letter, so I multiply those, which I can do mentally. I don't need a calculator for that. So 7, 3, 9, 8. Now divided by the number on the diagonal with the variable. So divide by 58.37 is, and I get 126. Then I have 7, 4, and the 4 is less than 5, so I round down, that is, leave the 7 alone. So 73.98 is 126.7% of 58.37. And so this must be somewhat more than 100%, and this is somewhat more than 100. And again, this word is replaced by the symbol for percent. You see, we didn't have to move the decimal point to convert it to a percent, because in fact this divide by 100 that we have built into the formula does a conversion to a percent for us. And that's the nice thing about this is over of method, is when you're done, you're absolutely done. If it was a percent, simply stick the percent on, because that's exactly what you have. Nice? I hope you find it. But please also note this, that these two sentences used exactly the same two numbers, but got two entirely different answers. And the point we try to make is that the numbers themselves does not constitute the problem. The problem is their relationship in the sentence. That is, how are those two numbers related? And the same two numbers are related, simply two different ways. Within more traditional consumer or business math, this type of problem for some reason brings the average beginning student to a complete halt. However, with either of our two methods in this lesson, this problem is no harder than either of the other two we've worked upon. You see, it has still the same sentence structure as the other. There is an is percent of something. So we simply replace our model or our formula by its appropriate number. So we start reading. We see the 428 is attached to the is, so it replaces the is. The 10.5 is attached to the percent, so it replaces the percent. The of is attached to how much, which in business circles they would call the number that's attached to the of the base. So we'll use a B, but any letter would have done. And 100 stays 100. Then by using our calculator shortcut approach, again, we multiply the 2 on the diagonal without the variable, and we can do that mentally. 42800. Then divide by the number on the diagonal with the letter, which is 10.5, equals, and then find out how accurately this is to be rounded. And let's say to the nearest hundredth, so we see it's 4076.19 to the nearest hundredth. So $428 is 10.5% of $4,076.19. See, this type of problem occurs fairly frequently when you know how much interest you've paid for tax purposes because you've just received your bill. And usually you know what the interest rate is because you've been dealing with that for year after year or month after month. But the base is changing from month to month or year to year. So frequently you forgot what this was, but if you know these two, this formula allows you to get at the solution. And you see this was no harder than any of the other problems we gave you, was it? And the mathematical tool that made it simple for us was understanding what a proportion was and being able to solve that proportion very quickly and smoothly. But you might be one of those individuals that's more inclined to the dictionary or translation method. If that were the case, you'd simply go down the sentence and start translating word by word. So 428 rather, is math. The is translates to equal. And this part here we can translate all at once if we wish. To get away from percent, we move it two places away, which gives me 0.105. Or else we could have taken 10.5, replaced the percent times 0.01, multiply the two, we would get this. Of translates to times, and how much is some variable. Call it n for number, call it b for base, call it x for unknown. The choice is yours. And you can see from our algebra review portions that to undo multiplication, you divide by whatever you were multiplying by, of course, but you divide both sides by the same amount. This undoes this, isolating the variable. Now on your calculator you just follow through with this, and of course you'll get exactly the same answer. There, just from watching this single lesson, are you beginning to feel a preference? Do you prefer the translation method, or are you one of the students who are beginning to prefer the is over of formula, which of course has an alternate form, the amount base rate formula? In time you will find yourself moving towards one or the other, but so that you can communicate with other people within your field, you should be reasonably comfortable in both methods. And as time passes, you'll find several others. So it's not a matter of forgetting one and just remembering the other. You should remember both so that you can communicate with other people. But then, of course, prefer one, if you wish, for personal work. This is your math host, Bob Fennell. We'll see you at the next lesson where we'll do some more problems somewhat like this one. Good luck.